All right, last time you finished number 19. Okay, the next number we try today. This is twice differentiable. That means the graph is smooth.
Yeah.
Increasing function of t, right? That is increasing means what? First derivative. Oh, this is g over here. First derivative is positive.
Mhm.
G over 0 is 0. Or g over 0 is 20. And g over 10. From here to g over 10 now. 220, right? Okay, 220. Which of the following must be true on interval t between 0 and 10? Okay.
Mhm.
When you take a look at the options there, g prime t is 0 for some value of t. Okay, that is a local maximum or local minimum there, right?
Mhm.
It's okay. And g prime 20, the derivative of some time t is 20. Okay. So actually this is a mean value theorem, right? 20 over here. When you over this one, maybe the graph this is differentiable and we have a slope of this line, right? Average rate of change. The slope of this secant is called what? AROC. Do you remember this one? Average rate of change. Okay. Average rate of change is what? G over 10 minus G over 0. That is change in Y over change in X is 10 minus 0, right? Check it out. 220 minus 20 over 10. 200 over 10, it is 20. Slope of this line tangent, secant, I'm sorry. Secant always a slope between 2 points. Because this is differentiable with smooth line, there will be at least one c there, okay, which has what? Same slope. This is we said derivative, instantaneous slope, right, at one point.
Yeah.
So there must be something like this one. There must be some value of c exist which has the same slope, f prime c, isn't it?
Yeah.
Okay, you can use you can use t, doesn't matter. Some value of t slope is 20 somethings, right? Okay,
Mhm.
slope is 0, we cannot guarantee there, right? Okay,
Yeah.
if you have this one, maybe slope is 0, okay. Okay, anyway, this one, okay. Sometimes value of t slope is 0. Is that possible? In this case, when you have a 2 over here, 0 over here, and 10 over here, 0 is 20, 10 is 220. Sometimes we have this one. Okay? All the way increasing, but there's no local maximum or minimum. Okay? There's no point C which has a slope is 0, right? Slope is 0, to have a slope is 0, you can use this one or this type of graph. Slope is 0, right? But this
Yeah.
there's no slope is 0, okay? So this is wrong. What that means, there is a inflection point there, g prime t equals 0 means there exists one inflection point. When you have this one, no inflection point, okay? Inflection point is why increase, concave up, always increase, concave down. So this point is called inflection point. But in this case, there is no inflection point. Is okay?
Yeah.
So it's all the way concave up. No, this one is concave down over here, okay? This is a counter example, concave down, not always true. But this one is always true because the graph is what differentiable. smooth line. Okay, that is a smooth line. Okay, any point C, there must be have some slope of this line. Okay, 20 here and here. This is okay too, right? Over here, there is just some volume sheet there, which has same slope. These two lines, they are parallel. Is it okay? So
Yeah.
this one is mean value theorem. Okay. To apply mean value theorem, okay, the sufficient condition must be differentiable. Okay. Number 21. Number 21. This was the second fundamental theorem of calculus. Second, FTC. You understand, right? First FTC, right? First
Yeah.
FTC is what is that? You just finished, okay? F of B equals what? F of A plus A to B, right? Sum of all this derivative, right? Between A and B. That is the first fundamental theorem of calculus, okay? A second fundamental theorem of calculus is this one. When you have, right, d dx, but this is any constant. You can use e or a, it doesn't matter, any constant. Up here, that is x cubed. I'm going to use it generally u, okay? U.
Yeah.
U is a function of x. If this is ft over here, when you have ft, take a integral with respect to x, but this is now function of x. But we take a derivative with respect to x again, so the rule is what? This u going into the t, right?
Yeah.
After that, this is a function of x will multiply to prime, okay? That's the second fundamental theorem of calculus, okay?
Mm-hmm.
This is the second one. This is inside the function of ft, and we take integral from constant to x cubed. So integral is a function of x. This one is, maybe I'm going to use, okay, it's a, okay, anti-derivative, we use this, okay, f of x. After that, dxd again, right? This is what? Derivative, I'm going to use f of x, right? If you have this one, f prime x equals f of x. Take a derivative one more time, that is f of x again, but no t, right? That is a function of x. That's why we switch the variable t with the x, okay? Now put this number x cubed inside t. So ln x cubed over here. Another x cubed square is x6. It's okay? And the plus 1. After that, you multiply the derivative. What is derivative of 3x x cubed? 3x squared. Alright? Okay. Now, this is going to first, right, to avoid the confusion. 3x squared and ln x to the 6 plus 1. That's the answer, okay?
Mm-hmm.
So where is the answer? Choice C is the answer, okay? That's number 21. That is number 22.
Oh.
As you can see, there are already this slope field, okay? The slope field is if you have initial conditions, initial value, you can get the graph of the solutions, the graph of y, okay? For example, if you got, for example, here, initial, we start from here. The graph looks like what is that? That is a slope is 0, right? So we follow the line over here approximately. That's the graph. Okay? This is the graph of what? Y. It's okay. If you have initial over here, you follow the slope, right? Follow the slope. This is the graph. That's the solutions. Okay? The graph of y equals f of x graph will be looks like this one. If you start over here, the graph looks like follow over here, right? Are you okay with this? So when x go to infinite, y close to 0, right? Because that's the slope is 0 over here, okay? Are you okay with this?
Yeah.
Okay, now let's find, okay, which one is the slope field differential equation. First of all, maybe in the middle is okay. Yep. In the middle, when the value of y equals 0, the slope is all 0, right? This is a group over here. They are all 0, isn't it? It's okay? If y equals 0, dy, dx, slope of this one, they are all 0, right?
Yeah.
So which one is satisfied? This one. The first one, when y equals 0, they're undefined. This is wrong, right? Is it okay?
Yeah.
This is wrong, undefined. But both will be what? 0, 0, okay? X times any value of x always what? Times y equals 0 is what? Slope is 0, right? This is okay, this is okay. So using this one, you can try the next one, any point of it. I'm going to use this point. I'm going to use this point, is okay too. This point is when x equals negative 3, when x equals negative 3, and the y equals 1, 2, right? 2. At this point, slope of this one, slope of line of tangent, the slope of this one equals positive, right? Around looks like 1, okay? Check it out. Put this number x and 3 and y is 2 at this point. X is 3, negative 3, y is 2 is about negative 6. Slope is negative 6, but this slope is about positive 1. That is not working. Okay? Now put this number, x is negative 3, y is 2, they are negative 3 times 2, this is what? Positive 6. There you go. Not 1, right? Okay, this is a positive, any positive is okay. So this is a positive. Okay, so this slope field is for this differential equations. Are you okay with this? You understand this number 22? They always give these questions every test. Do you remember this one? Slope field?
I do.
Okay. All right, number 23. Using the substitution, u equals x plus 1. Okay, that's use substitution. And which one is equivalent? Yes, they are all replaced with what? U. It's okay. All right, x plus 1 is u. That's u. Okay. But we replace the x dx over here. Du equals x plus 1 and x plus 1 test. U equals x plus 1 and du equals what? Dx. It's okay? Now replace with dx du. It's okay?
Yeah.
What about x? Oh my god. We have only x there. Dx is replaced with du. This one is replaced with u, but what about x? From here, right? We can switch, okay? The variable. This is we said was switch variable, okay? X is already there. X equals u minus 1. Are you okay with this?
Yeah.
Yeah. Yeah, usually this is we said change of variable. That's possible, right? So it will be no problem. So x is now replaced with a u minus 1. and dx replaced with du. That's it. But simplified, okay? U over square root u is what? Square root u, okay?
Yeah.
1 over square root u. We have this one. Oh, they're going to use exponent form, right? This is the exponent form, okay? Square root u is what? U to the half minus 1 over u to the half is negative 1 over 2 and du, okay? So choice C is the answer. Are you okay with this?
Yeah.
Use substitution. All right, number 24. Let f be the function given by f of x is a polynomial function there. For what value of x does f have a removal discontinuity? Removal discontinuity, what is that? When they have a common factor and cancelled out, they create removal discontinuity, right? This removal discontinuity, another name is a pod. Okay? All right. Now, take a vector, okay? Vector over this one. 2 is out, numerator. Inside brackets is x squared plus 7x and minus 8. Denominator, again, we can fact denominator. X squared minus 9x plus 8 is what? X minus 1 and x minus 8. But numerator can be factored this way. X plus 8, x minus 1 over x minus 1 and x minus 8.
Okay.
This is a common factor. When they cross out, they create what? Pod. If we don't have x minus 1, okay, compare this. If we have this one, 2x plus 8, and denominator x minus 8, x minus 8, x minus 1, x minus 8. But there's no common in this case, right? There's no commons. So there are the two vertical asymptotes, x equal 1 and x equal 8. There are two vertical asymptotes. Are you okay with this?
Yeah.
But we have a common factor over here, x minus 1 cancelled out. So x minus 1, x equal 1, right? X equal 1 is not anymore vertical asymptote. It's okay? So instead of vertical asymptote, we create a pod. This one is, if you understand by telecommunications, it's possible, right? Because that is right design of electronics. When x minus 1, okay, this is what closure undefined means what there are x equal 1, a lot of noise there. This is noise, that difference, okay? One is infinite, the other negative infinite. A lot of noise, right? That is noise. But if you put in the right new x minus 1 in numerator, we repair this noise, looks like this way. Somewhere over here and make a pod. That's it. But this one is our human being, okay? Our ear cannot recognize this noise, okay? All right? Okay. So this one is what actually electrically right the design, okay? The circuit design. We use this one, okay? But this one is anyway that you canceled out no more vertical asymptote, but instead of vertical asymptote, they are create what POD, okay? Where? When x is 1, okay? Okay, 1 only. X equal 8 is still what? Vertical asymptote. That is not pod, okay? That's number 24. Number 25. Which of the following is a solution to the differential equation? Y second prime minus 4y equals 0, okay? Y second prime minus 4y equals 0. So without, okay, this given options, it's a little hard. That is not separable. Okay, this one has, we have to use some other different way. Are you okay with this?
Yeah.
This is actually we use a Laplace or S, okay, Laplace transformations. Okay. So in this case, but high score, you don't have to solve, right, using the other method. Okay, just right. Put this number in there. It is equals to 0. That is the end. That is the solutions. Okay. So anyway, second prime. Okay. Okay. Why is it solutions? Check it out. Y first prime is e to the 2x n times 2, right? Y is the second prime times 2 again, 4 times e to the 2x. Check it out. 4 times e to the 2x minus 4 times y is e to the 2x. Is this 0? Yes, that is 0, right? That's the solution. That's the answer. Okay, I'm going to check out the second one over here. Y prime is 2 to the 2x. I'm sorry. Y is 2 to 2x and y. Okay, same. Looks like different, right? Y prime is 2 to the x, right? Nothing changed. Y second prime is also 2 to the 2x. Now replace over here. 2 to the 2x minus 4 times y is this one, 2 to the 2x. Not equal 0, okay? This is a 2, this is a negative 8. Are you okay with this? Okay, draw one more over here. Y first prime is cosine 2x, so 2 times cosine 2x. Second prime is what? The prime of cosine not negative, right? Negative sine 2x, another 2 there, in there. Okay, inside I change the 2 again, so negative 4 sine 2x. That is the second prime. Okay, put this number in there. Negative 4 sine 2x minus 4 times y equals how much? Sine 2x. That is not equal to 0, okay? That is a negative 8. That's not solutions. Only this one is working, okay? So I'm not going to do this one, okay? That's not working. Do this way, okay? If not, okay, you have to use s squared minus 4, s equals 0. S is s minus 4 equals 0. We have right 1 s equals 0. S is 4. Okay, not this one. Okay, forget it. Okay, when you have right not separable, okay, this is your second order equations. Okay, that's not first order. Okay, this 2 dot is what you set second order differential equation. When you have a second order differential equations, just try all options until you find the solutions. Okay. Number 26. You have 5 selected value of x and its value of y. Table above gives the values of continuous functions f at selected value of x. F has exactly 2 critical points on open interval, okay? Continuous functions, continuous. And there is a critical point, okay? What is the critical point? Yeah, at prime, okay, some value of x is what? Slope is 0. That is you set critical point. Because this is continuous, so maybe sometimes you can have this one too. Right? At this time, so what is that? F of A is undefined, okay? But this is also called what? Critical point. Are you okay with this? So definition of critical point. Definition of critical point. f of x equals 0, or f of x is what? Undefined. Oops. Okay. We'll take them out. Oops. Undefined, okay? This is undefined, but this is still called like critical point. This is also critical point, if this is correct. Or maybe graph look like this way. At this point, the slope is what, 0, right? This point also a critical point, okay? Belongs to over here, okay? So there is a two critical point on open interval. Okay, which of the following must be true, okay? So 10 over here, 11, 12, 13, and 14. That is 5. Second is 2, 3, 6, and 5 again. Something like this way. That's possible, right? Two critical point. If possible, it looks like the graph looks like this. Okay, yeah, at these 2 points, we have right slope of tangent or derivative is 0, okay? Or this can be, this is okay too, right? Undefined, still two critical point. All right, so which of the following must be true using this one, okay? F of x is greater than 0 or the x. If this is x is all the way greater than 0, the graph always looks like this one. Graph is this way. They are already greater than 0, right? The value of y, all this on y coordinate on this graph already positive. That's fine, right? But it doesn't have to be already this one. Take on the second one. Okay? So between 2 points, we don't know what happens there. It can be positive, it can be negative. It is okay? But this is not always true. Okay? Alright. Now the second one. F prime existed. F prime means what? Derivative exists for all x. That means what? The graph of x, the f of x is already differentiable, right? Differentiable between 10 and 14. But this is differentiable, it's okay, right? This is differentiable. What about this one? This way. This is continuous. They didn't say they are differentiable, right? Just we have critical point. One critical point, two critical point. But this is not differentiable. Okay, we have a sharp corner there. Looks like this, okay? Sharp corner. That is not always true, okay? Delete. This is wrong. Not take group number 3. F prime x is less than 0, is the graph is decreasing for all x on interval 10 and 11. 10 and 11 already decreasing. What about this one? Increasing and decreasing, right? That's possible because there's no information between any 2 points. Right? It is increasing, decreasing, right? Not already decreasing. That is wrong too. Oh, very dense anyway. Take a look. The number D there. This is wrong. F prime 12 is not 0. F prime 12, where is 12? Here. 12 is over here. What happened?
It's in the middle column.
Exactly two critical points.
So it would be like when it changes this changes from going
That's right.
increasing.
Because what?
I mean,
Two.
going up to down.
Okay, let me check this one more time. Okay. The slope of at the tangent line at x equal 12 cannot be 0. Okay. We have two critical points. This is anyway up here and the down over here, increasing over here, right? It's okay?
Yeah.
So they're gonna have anyway up here, down over here, this way, okay? They're gonna have some critical point there. You see? Critical point is what is there? Decreasing and increasing. Is it okay? If you have point over here, you have 3 point over here. Okay? Decreasing, increasing, there is what? Always what? F prime c equals 0 or F prime c equals undefined. Okay? That is a critical point. So that's the point. This is what? Up here and the down over here, this is increasing, right? So between these two, there will be one critical point. Around over here, one critical point looks like this one. From here, increasing and decreasing around the somewhere here, right? Around somewhere, not only this point. Okay, not only this point. Also up here. Anyway, they're going to decrease this point still what? There is another critical point.
Yeah.
Are you okay? Yeah, we have two critical points already. Exactly. Over here, exactly. Okay? There are exactly two critical points. So this one cannot be critical point. So it cannot be right critical point, right? That is what? Not equals 0, okay? Critical point must be equal to 0, but this one cannot be. We have the two already over here. One over here, the other one over here. So this point cannot be right. Slope of tangent line equal to 0, okay?
Yeah.
So choice D is correct, okay? Number 27, positive variables P and C change with respect to time t. Okay. Variable P is a function of x, and C is also a function of x. I'm sorry, function of time. Time, right? T. Okay. The relationship between P and C is given by the equations. This is the relation equations. P squared equals 20 minus C cubed. At the instant, okay, at the instant, dp over dt, all right, instant rate is 41 on this function over p. And the C is found. The situation is what? At this moment when C is 15. What is the value of dc dt? Is okay? So from this given, you're gonna find dc dt.
Yeah.
Instantaneous slope at time dt. At this point, C is 15. This is the equation of relation between these two variables C and P. Okay, now take a derivative, right? dp dt. So 2 is moved down, 2p, after that dp dt. It's okay? Because p is a function of time. Now the next one, we're gonna apply the chain rule, right? 3 moved down, 3 to the 20 minus c to the 3 minus 1 is a square, After that, we multiply negative c, okay? Negative c is what is that? Negative dc over dt, isn't it? This is a liberated rate, okay? This is we set the liberated rate. But we need to find the value of P2. When C is 15, this is the moment. When C is 15, what is the P? From here, we can find the P, right? Put this number, C is 15 there, we're going to find the P. P square. Already variable positive, okay? P square is what? 20 minus 15, C is 15, and the cube. How much this one? 20 minus 5, 125, right? From here, P is positive, square root 125 is about 5, red, 5.
Yes.
It's okay? 5 red, 5, right? All right. So when C is 15, P is 5 red, 5. Okay, put this number P in there. 2 times 5 square root 5 is what? 10 red 5. After that, dp dt is 41 there, times 41. That is exactly equal 3 times 20 minus c. Okay, 20 minus c is 15, 5. This is 5 squared is 25, okay? After that, minus, I'm going to move out, and the dc over dt. Now we need to find the dc over dt of over here, okay? Okay, dc over dt equals, you can divide by negative 75, both sides, okay? 10, okay, 10 times 41, or it doesn't matter, times and 41 over negative 75, okay? Okay, 41 divided by 5 of course, that is 2 divided by 5 is negative 15. This is 41, confused. There is no common factor, right? So 2 times 41 is 82 square root 5. But the denominator is still negative 15, right? So put this negative out 15. That's the answer, okay? So where is this answer? Over here, choice D. Is it okay?
Yeah.
All right. Number 28. This one is x close to. We can try, okay? Positive first. Okay. I don't know this one, okay? 3 plus 2 to the x. 4 minus 5 to the x. Put this number negative, positive. This is infinite. Denominator negative infinite. Okay? This is familiar, right? The ratio to we can apply the L'Hopital's rule, okay? Okay. Apply the rule there. The derivative of 2x is still 2x. That's correct? No? ln 2, right? Yeah, that is not e. Base number is different, okay? Always we multiply by ln 2, okay? Denominator 5 to the x. This is ln 5. Okay? But still I keep going. One more times. Still 2x ln 2 square. Is okay?
Yeah.
So negative 5x. Another is ln, one more 5 square. Getting increased. But this is not positive infinite, right? So we cannot find, right? You can find anyway. Okay. Okay, we try. Okay. Do this one, maybe we can try it. Okay, I'm gonna apply this one. So the limit, this is actually what it is. X go to infinite. It's okay. X go to infinite. So this is very small, right? Forget about this one. We don't care about this, okay? Are you okay with this?
Yeah.
This is actually equal to this one. 2 to the x over negative 5 to the x. What is this one? Limit x close to infinite. Same exponent inside the number, we can put it together, right? X. Are you okay with this?
Yeah.
So when x go to infinite, this is what inside is what? Less than 1. It's okay? But greater than negative 1, okay? We don't need the absolute value. Okay? Inside the number. Between this one, always what? When x go to infinite, close to 0. Are you okay with this?
Yeah.
Right. So we have 0 there. Now we can try the next one, the other side. X go to negative infinity, okay? Plus 2 to the x over 4 minus 5 to the x. When x to the negative, what is this one? 3 plus 2 to the negative. 4 minus 5 to the negative. 2 to the negative, what is that? 1 over 2 to the infinite, right? That is close to 0. This is also 0. So in this case, 3 over 4 is the answer, okay? But I think, right, x go to negative infinity, okay? Both, okay? Check out the both, okay? If x go to a positive infinity, the answer is 0. X go to a negative infinity, the answer is 3 over 4, okay?
Yeah.
I think it looks like a negative infinity. But in this case, C is more, okay? Understandable x. Answer, okay? Alright. Alright, number 29. Yet the graph of function g and line y equal x are shown in the figure above. The graphs intercept at point 0, 0, 0, 1. Okay, this is 1, 1, okay?
Yeah.
And the 2, 2 there. Okay, they gave a right intersection already. Which of the following expressions give the area enclosed by the area is about positive, right? They say, okay? Enclosed means what? Positive area. This area, this area. But this is the top. But at this time, this graph is the top. This is the bottom. Another bottom graph. Okay? So y equals x. Curve is y equals g of x, okay? Curve is y equals g of x. So first one from up to 0 to the 1, area is what? Top is what? G of x. The bottom is x, dx, okay? Now 1 to 2 is what? Which one is the top? Y equals x is the top, minus bottom is g of x. That's the answer, okay? So which one is equal to this one? First one is okay, 0 to 2. When you have help here, because they are just symmetry, okay? Because the y equals x is what? This graph, always what? Same area. It's okay? But when you take a 0 to 2 area, this is the plus area, because what? This is the top end going down, this is negative area, right? It's okay? X minus, over here, x minus gx. This one minus this, actually this is the minus area. This one, the x is the top minus this is a positive area, plus minus 0, this is 0. The area of this one is 0, right? That is not the answers. Are you okay with this?
Yeah.
Okay. The next one is x minus g of x is what? Always this is a positive. Okay, take a look. I'm going to express this one. 0 to 2, okay? top is what? G of x is greater than f of x, okay? It's okay? So we're gonna put the one more negative sign there, okay? So negative x minus g of x dx until we are up to 1, okay? Until up to 1, okay? G of x is greater than 1, right? G of x is greater than x, that is a negative sign, okay? To make a positive. After 1 to 2, now x is at top, g of x is the bottom there, that is always positive. We don't need the absolute value, okay? X minus g of x dx. This is exactly the same as this one, right?
Yeah.
Minus x, this one is a minus x plus g of x. G of x minus x, same thing, okay? So it's equivalent, just for different expressions. Okay? All right. Usually we use this one, but when you calculate this real area, we divide by these two, okay?
Yeah.
All right, number 30. A student attempts to solve this differential equation dy dx. I'm going to write that. dy dx xy cubed. Initial is y equal to, when x equals 0, y is 2, okay? That when x equals 0, y is, that is initial, okay? You can use this point. The steps to the solution are shown below. In which of following steps does an error first appear? Anyway, this one is separable, right? Times dx both sides. dy equals y, x times y cubed dx. Separate all variable to the left divided by y cube is 1 over y cubed dy equals x dx. Okay? Step 1, take now integral, right? That's fine. This is okay. Okay, after separable, we continue step, the next one, okay? The next one is y 1 over y cubed. Antiderivative. Is this a ln y cubed? No, this is a polynomial, right? This is actually negative 1/3. Are you okay with this?
Yeah.
dy. This is actually the plus 1 is y to the negative 1 divided by negative 2, right? That is not ln, okay? Step 2 is wrong. Are you okay with this?
Yeah.
So the first appear error is what? Step 2, okay? ln is y, 1 is y. This is the ln absolute value of y, okay? But this is a 1 over y square is not ln, okay?
Yeah.
That's a polynomial antiderivative. That is number 30. Now, from now, we can use our calculator, okay? The graph of f prime, the derivative of functions f is shown above for negative 3 to 3. On what intervals is f is increasing? This is the graph of f prime, okay? Only f prime gives us what? Information by increasing and decreasing. Additional, maybe we can say concave up, concave down, because we can find what? The slope of this line. But they're asking you only what? Increasing. Decreasing, increasing, increasing. That's right? Where is increasing? Negative 1, 2, 3.
Yeah.
Okay? Negative 2, no. In this section, they are all decreasing, here increasing, here increasing. Is okay? Choice B is the answer. But this time, so what is there? At this time, what is there? Increasing, a little standstill, now still increasing, right? But this is okay, it said what? Increasing. If they said what? Strict increasing. Actually, we eliminate this, okay? Strict increasing means what? The answer is now what is that? From sometimes, okay, this is bracket, it doesn't matter, okay? Sometimes we don't include the bracket, we don't use the bracket, okay? But sometimes including the endpoint, it doesn't matter, okay? Anyway, we're gonna find the best answer, okay? So you can use this one. Okay, if it is strictly increasing, we have to say this one, negative 1, 2, 2 increasing, okay? Continue 2, then infinite, or 3, okay? 3 is our last one. 3 is increasing. It's okay?
Yeah.
But we eliminate this one, okay? Because that is strictly all the way increasing. But this one is what? Increasing here, another increasing, okay? So I'm going to show you the graph of the real function of a graph, the graph of original function, okay? I'm going to overlap with you. Okay, we can start any initial conditions from here. Any initial, it doesn't matter. From here we start. That is decreasing, okay? Slope of this one is what? Negative. Concave down, decreasing, right? At this point is what? Inflection point. Are you okay with this?
Yes.
All the way inflection point. But concave down increasing. This is concave down increasing. After that, still, I'm sorry, decreasing, right? Decreasing over here at this point. At this right point of inflection, slope is positive, concave up, decreasing, okay? Concave up, decreasing from negative 1 there, okay? Concave up, decreasing from negative 1. After that, increasing, right? From here, increasing. But slope is positive. Increasing what? Slope is positive, concave up, increasing, okay? Concave up, increasing.
Yeah.
At this point of inflection again, right? After that, still increasing, but slope is what? Negative, concave down, increasing. Up to 2, right? Up to 2. I'm going to make it up to 2. Concave down, increasing, something like this way. Are you okay with this?
Yeah.
After that, still increasing, right? This is what? 0, but still increasing. Concave up, increasing. Okay? That's the graph. Okay, up to 3 over here, right? Finish up to 3. So, where is this strict increasing? From negative 1, right?
Yeah.
All the way 3, okay? All the way 3. So I'm gonna this one. From here, or sometimes include this number or open, it doesn't matter, okay? Increasing, okay? All right. But sometimes they use this one, negative 3 and 3 is okay too, right? But they don't give away both of this one, okay? This one or this one, okay? Let me see. Number 77. The rate at which water leaks from a tank in gallons per hour. Yeah, they're leaking, okay? Gallons per hour modeled by R, okay? R, that is the rate, okay? Right. Function of a number of hours after leak discovered. Which of the following in best approximations are prime 1? R prime 3, okay?
Yeah.
This is already rate. It's okay? There is the original over here. function of antiderivative, this one, I'm going to use what? Capital large T, okay? The derivative, this is derivative, right? Which is the rate, okay? The looking gallons per hour. This is already rate. But its derivative is over here.
Yeah.
What time t0? Over here, at time t equals 3 over here, this rate is what? Increasing, right? The rate is increasing. Are you okay with this?
Yeah.
Rate is increasing because what? This is x is 3, right? Positive. Is it okay? The rate is, if this is a positive, right? This is positive. Where is the questions? A prime, okay? If this is a positive, that is increasing. This is a negative, that is a decreasing, right? The graph looks like this is decreasing rate, okay? All right, that's the meaning. Amount of water in gallons, it has leaked, not amount of letter, okay? No. The rate is decreasing, not amount of water, okay? That's the difference. Amount of change in gallons per hour, no, okay? Not change. Not amount of water change, okay? The rate is changed. The rate at which water leaks from tank in the gallons per hour, after that is discovered. That's the answer, okay? The rate. This is the rate, okay? The rate of change of the rate at which water leaks from tank in gallons per hour per hour. Oh, this is the correct one. 3 hours left discovered. This is the correct one. Okay, this is per hour. Another derivative is what? Another hour square, okay? That's the unit. But what happens over here? Gallons per hour, no. The unit improper, okay? Per hour square. Are you okay with this?
Yeah.
This one is amount of water gallons. The rate is what? Per hour. Another rate is what? G, another hour, right? That's what hour squared. This one is wrong. Per hour is okay, right? This is hour square. Are you okay with this?
Yeah.
Okay, this one is many times they gave this one. I remember 2019 we got almost same as this one, okay? The number 78. A particle moves along the x-axis. Okay, the horizontal, right? Not y-axis. The velocity of particle at time t is this one. This is velocity of time t is what? 4 over t cube plus 1. That's correct, right? T cube plus 1. Okay. If the position of particle x equal 1, time t equal 2, x is 1, okay? That's the positions. What is the position of the particle at t equals 4? We're gonna find what? T equals 4. This is also a fundamental theorem of calculus, right? Between what? This value. X is 4 equals how much? X over 2 over here, but we're gonna take all change right between 2 and 4 over here. BT, right? This is x prime is what? Velocity. 4 over t cube and plus 1 dx. That is what? FTC. I remember this one?
Yeah.
Now this one actually we have to use our calculator, okay? Or if not, we have to use substitution. No, use substitution. No. It's not. with, okay, this one actually a partial fraction, okay, it's hard, okay. Without using calculator, you have to use this one, t cubed plus 1 and t plus 1, t squared minus t plus 1, right? Over 4, you're going to separate this one, t plus 1 over a plus b, t plus c over t squared minus t plus. Using this partial fraction, this is ln, this is u substitution again, right? That's right. But it takes too much time because we can use our calculator, okay? Use our calculator. Take a look at me. I'm going to put this number. x2 is 1, right? 1 plus. And integral. Oh, take integral. Take them out, the integral over here. But you know how to use your calculator, right? To find the integral, right?
Mm-hmm.
From 2 to 4. 2 to 4. And the integral is 4 over t cubed. It's good. T cube, okay. T cube and plus 1. And dx, dt, okay. 1.353, okay. 1.35. Take a look. Choice, okay. 1.35. Choice is that, okay. Are you okay with this?
Yeah.
When x is 2, this is 0, right? When x is time 2, particle over here, 1. Particle over here. When t is 1. T is 2, a little to the right. A little to the right. When t is 2, particle is now 1.353, okay? This is 0, okay? This is x. Okay with this? You can use with this one over, or you can use the xy plane, right? Time over here, x over here, okay? When t is 1, it is 1 there. When t is 2, it is what? 1.353, okay? So we followed what the graph of this one, okay? If this graph looks like this, came down. Okay? Yeah, this much change. This one is 2 to 4 over t cubed plus 1 dx, okay? Okay, we'll continue next time, okay?
Okay.
So after class, okay, review, all right? As much as you can, okay?
I
To
will.
complete figure out all the questions, okay?
Okay.
All right, okay. Good job today. Also next time, okay?
Okay. Thank you, Dr. Chung.
Okay, you're welcome. So you have a good night, okay?
Okay. Have a good night. Bye.
You too. Bye. Time is it? What's the date?